Good morning, everyone. I am Navin from CSC department. Today, I am going to present my C21 AI Immersion activity on Inside Large Language Model. In this presentation, I am going to explain how a large language model processes text starting from tokens and embeddings, and also then how the transformer architecture uses self-attention. I will also cover query, key and value, prompt engineering, context window, multimodal AI, and finally responsible AI usage. The full architecture and also embeddings and also transformers is deeply we explained that video. First of all, we enter the LLM. What is LLM? First, let's understand what a large language model or LLM actually is. An LLM is a neural network that is trained on a large amount of text to learn pattern and relationship is in language. When we give prompt to LLM, it does not directly understand the sentence in the same way the human do. Instead of the input process as tokens, and the model use the learned representation to predict the next likely token. For example, if I give the sentence the sky is, the model may predict blue as the next token. This process is repeated to generate complete response. LLM are used in many applications such as question answering, coding, assistance, summarization, translation, and content generation. So the simple idea is input contents, process the token, predict the next token. So the flow was text, token, embedding, transformer, self-attention using Q, K, and V. It means query key values. Context our representation, next token prediction. The next part is text, tokens, and embeddings. Now let's see how the text becomes something the neural network can process. The first step is tokenization. For example, the sentence the cat is tired. The cat is tired can be divided into tokens such as the cat is tired and the period. The exact token can depend on the tokenizer, and sometimes a word can be split into smaller subwords. Next, each token is mapped to a numerical ID, but an ID by itself does not contain enough useful information for neural network computation. So the next step is embedding. An embedding represents a token as a vector of numbers. For example, we can represent the word cat using illustrative vectors such as 0.21 minus 0.45 at actual 0.73 and so on. These vectors allow the neural network to work mathematically with token representation and learn useful relationships between them. So the overall flow here is text, token, token ID, embedding. The next part is transformer. How text is processed, it means transformer. Now we come to the most important architecture behind modern LLMs, the transformer. The transformer takes token representations and process the relationship to build context over representation. First we have the token embeddings. Positional information is also included so that the model has information about the order of tokens. Then come self-attention. Self-attention allows tokens to interact with other tokens and determine which information is relevant. After attention, the information is processed by a feed-forward network. This process is organized into transformer layer and multiple layers can be stacked. For example, consider the cat is tired because is tran. They understand the word it, the surrounding context is important. So the transformer uses relationship between tokens to build a better representation each token. The main idea is transformer allows tokens to interact and build context over representation. So tokens are very important and also at the same time transformer is the architecture of LLM for best example to uh, evaluate that prompt. The next part is self-attention. It's also conclude to query, key, and also value. Now let's look at the most important mechanism in the transformer, self-attention. To understand this, I will use a simple example. The cat sat on the mat because it was tired. Suppose the model is processing the word it. The model needs contextual information to determine which other tokens are relevant. This is very query key and value come in. Query or Q means what information may I looking for. Key or K means what can I match with, and value or v means what actual information do I provide. We can compare this with a library search. The query is like the search request. The key are like labels or information that help us find relevant books. The value are the actual information inside those books. For the word it, its query is compared with the keys or other tokens. If a particular token is more relevant, it receives a higher attention weight, then the corresponding value contribute more strongly to the new representation. So the simple flow is query, keys determine relevance, attention weights values. Next, attention worked example. Let's trace the same example more carefully. The sentence is the cat sat on the mat because it was tired. We focus on the token it. First, it produces a query. The query is compared with the keys of the other tokens. The model calculates relevant scores. Then a function called softmax converts the scores into attention weights. If the token cat receive a relative high attention weight, its value contribute more strongly to the representation of it. This does not mean that we should think of the model as having a human-like thought such as I know this is differently the cat. Instead of the learned parameter produce representation and attention pattern that are useful for predicting tokens. The important thing to remember is Q asks what is relevant, K helps measure the match, and V produce the information. So these are the query values and keys. The attention weights is simple example like this are illustrative. There are not fixed values from the actual model. Next part is prompt engineering. Next, let's look at prompt engineering. Prompt engineering means designing our instruction to get a more useful and focused response from AI model. For example, a weak prompt would be explain transformers. This does not specify the audience of the expected level details. An improvement prompt would be explain transformers to a third year CSE student using a simple real world example, cover self attention and query key and value. This prompt gives the model more specific instruction. We can also use techniques such as zero shot prompting, few shot prompting, role prompting, and structure instruction. A good practical tip is specify the audience task format and important concept that we want to the model to cover. So better instruction can help us more focused and useful outputs. So next part is context window and multimodal AI. Now let's discuss two important concepts, context window and multimodal AI. A context window refers to the amount of information that model can consider within a particular request or conversation. This is the main concept of context window. This capacity is finite. It will provide more information that the model can handle within its available context. Some information may need to be truncated or omitted. So, when using a LLM, I mean large language model, it is useful to provide the most relevant information. The second concept is multimodal AI. The multimodal AI is traditional language model, mainly work with text, but multimodal AI system can work with only generated prompts. So, and also the LLM was work with multiple types of information. This can include text, images, audios, videos. These are the main components of LLM. So, for example, we can upload an image and ask the AI to describe the image or answer a question about it. So, multidimensional, I mean, multimodal AI allow us to interact with AI using more than just text. So, context window and multimodal AI is the main difference is multimodal AI is more efficiently interact with our prompt. Hands-on ChatGPT versus Gemini versus Claude. I used three models: ChatGPT, Gemini, and Claude. These are the main LLMs. I work with same prompt and individually give some of the AI tools. For the hands-on comparison, I used three LLM platforms. First one ChatGPT, second one Google Gemini, and third one Claude. I used the same transformer related prompt for all three platforms so that the comparison would be fair. The prompt was explain transformer self attentions to third year CSC student. Use one real example and explain Q, K, and V. Nothing but query key and values. From my observation, ChatGPT provides a clear step-by-step technical and also teaching style. Gemini provides a more technical and academic explanation, including more mathematical and architecture details. Claude gave a balance between intuitive explanation and also technical depth. For example, the three platforms used different example and different styles so to explain the same concept. So many, my conclusion from this hands on comparison is not that one model is always the best. Instead of, I observed the same prompt can produce different level of details, structures, and also explanation style across different LLM platforms. So we use the three platforms different styles and architecture, which is where you want more technical related questions, use Gemini. You want simple and basic level, you understandable level questions, use ChatGPT. You like architecture and diagrams and also depth knowledge, you go to Claude. So these are the difference between Claude, ChatGPT, and also Gemini. The next is responsible AI and key takeaways. Finally, let's talk about the responsible AI usage. AI generated information should be verified, especially when the information is important. We should also give proper attribution to source and maintain academic integrity. AI can be very useful for learning, research, and understanding difficult concepts. However, we should not submit context that we cannot explain ourselves. The main concept we learned can be summarized as text tokens embedding transformers self-attention using QV and V context awareness representation. Next tokens. The important idea is the LLM learn patterns from large lang amount of data, process token as numerical representation, and use transformer mechanisms to build useful context. Thank you.